Welcome to the much delayed and forgotten about 9.1 Geometry Journal Vocab Notes and Practice. Pythagorean Theorem starts on page 244 in your journal. Please open up your book to that page, to the appropriate page, 464. Try to follow in some of these, and let's get rumbling. I will tell you I have my book open to 464. And also remember, you'll learn more looking these up, finding them on your own, than you will if you just copy down the minimum. All that reading you do looking for the answers is extra studying, extra material you're getting in there. So give them a shot. If you can't find it, use the video. Don't forget to use your pause button. Pythagorean Triple, okay, is a set of three positive integers which satisfy, surprise, surprise, I hope you hit pause, the Pythagorean Theorem. Okay. When you set this up, remember this stuff over here in the green. The legs are these sides that meet to form the right angles. The right angle. The hypotenuse is across from the right angle. When we talk across from an angle, we're going between those two sides. We're not going down a side. Okay, that's not going across from the angle. It's going between them. That's not going across. So you're going between them. Even if I'm just getting to the edge of that side, it's still the same side. That's the opposite side, the hypotenuse. Okay, so Pythagorean Theorem. They got it over here. Notice, not the way you learned it before. I like that c squared on the left. You can use it on the right. It causes problems later. I mentioned the future problems here. Remember, better than that is this. Hypotenuse squared equals blank squared plus legs squared. Remember, use those pause buttons before you answer these. Legs squared. Most important. I don't think we're doing these. Set it up over here. So I got this example in the purple. Okay, this is my hypotenuse. This is a leg. This is a leg. So that's going to be x squared. Hypotenuse is always your c. And that's 4 and 6. You can go through x squared equals 16 plus 36. X squared equals 52. Square root, so x equals square root of 52. We need to break this down. I haven't done enough working with you on this. We generally don't put these in decimals, so you've got to think about 52 as 1 times 52. 2 times 26, 3 doesn't work. 4 times 13, I think that takes care of it. Ooh. This 4 is a perfect square. I can take a square root of that. Square root of 4 is square root of 13. That's 2 root 13. Okay? Really comes down to knowing multiplication. If you don't know your multiplication well, practice these. Use them better. I got lots of nice little tricks for figuring out what multiplies to a number. Now, one way of making life easier is these Pythagorean triples down here. Okay, we mentioned this up here, Pythagorean Triple, a set of three positive integers which satisfy the Pythagorean Theorem. We just looked at the Pythagorean Theorem. In a right triangle, the square of the leg of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Hypotenuse squared equals leg squared plus leg squared. C squared equals a squared plus b squared. I don't like to use the c squared because all somebody has to do is put a letter c on a leg, and you're messed up and you're going to get it wrong. So I'm never thinking about that A, B, and C. So Pythagorean triples. I showed you in class, or I will show you in class, thousands of these. These ones that I have underlined in the orange are the 4 you need to remember. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. If you know these, you know a bunch of others, because you can multiply by 2 and get 6, 8, 10. You can multiply by 3 and get 9, 12, 15. You can multiply by anything. That's what they mean by 3x, 4x, 5x. As long as you're multiplying them all by the same number, that's a triple. So, again, it comes down to knowing multiplication well. Same for the 5, 12, 13, 8, 15, 17, 7, 24, 25. Also, divide works. Remember, dividing by 5 is just multiplying by 1/5. So I could have 7 over 5, 24 over 5, and 25 over 5, which is 25. Whoops, I meant 25 over 5 comes up to 5, not 25. I just said 25. Don't know if I paused it before or after that. So when I do things, I like to do things the easy way. I look for the triples first. Okay? So I'm looking at this. I know it's 4 times something. That's just a hint. I see x, 60, and 68. Well, the 5's got to go to the hypotenuse. I can't make the 5 go into 68, even though I make the 4 go into 60, so it's not my 3, 4, 5. Okay? 12 times 5 is 60. So that's working, so I'm checking that out. 12 times 5 is 60. So, well, I wouldn't put a 12 there. So I'm thinking 5 times 5, 12, 13. Well, hey, I'm noticing I get the 60 there. When I do 5 times 13, I get 68. I don't get 68. What am I thinking? I get 65. Geez, that doesn't match the 68. That doesn't work. The 5, 12, 13 doesn't work. Okay, 15. I see that one. 4 times 15 gives me 60. That works pretty good. So I'm thinking 4 times 8, 15, 17. So this one works. 4 times 17. Plug it in my calculator, 68. Ooh, if those two works, I know this one's going to be 32. I get x equals 32. The more you do these, the better you'll get at them, and you'll start noticing them. A lot easier than thinking, oh, okay, 68 squared equals x squared plus 60 squared, and going through and solving it that way. You'll still end up with 32. A lot more work on the calculator. But I always look for those triples. I always look for the easy stuff first. Converse of the Pythagorean Theorem. Remember, converse, if our original statement is if A then B, the converse is if B then A. So this one we're saying, if it meets the Pythagorean theorem, then it's a right triangle. Okay? I mentioned the biconditional statement, that's putting them together. There's our if and only if. Big key on this, the longest side is going to be C. So whichever side is the largest one, that's what you put in for C, the potential hypotenuse. Now, related to this, we have the Pythagorean Theorem inequality. So this is the one where we really need, I really like the C squared on the left, because that way our less than fits with acute and our greater than fits with obtuse. So you can see those greater than obtuse, less than acute. That's a more logical fit for me there. Okay, so we basically have these, I think of these three together. I think, okay, if it's equals, it's right. If it's less than, it's acute. If it's greater than, obtuse. But we have to do one thing first. You have to make sure it's a triangle. So Theorem 611, which I don't think we covered this year in 2021 spring, verify the segments make a triangle. We have to make sure the two short sides will add up to more than the long side. So I've got that written out right there. So I'm going to go over here. Okay, 5 plus 8 needs to be greater than 11. 13 is greater than 11. This checks out. I can make a triangle. If it's equal or less than, I can't. So that's the first thing I do. Second thing is, now I plug it into my theorem. So I'm going to go, okay, 11's my longest side. That goes where the hypotenuse or C would be. I got 5 squared and 8 squared on the other. 121, I'm going to compare it to 25 plus 64. That's 121, and I'm comparing it to, what's that, 89. Geez, this is larger. Greater than tells me this is an obtuse triangle. Okay, so having some problems with the recorder. One way you might have done this, a little tougher on this one as a triple, 3, 4, 5. Oh, 3 times 27 is 81. 4 times 27 is 108. 5 times 27, I believe, is going to be 135. Just doing this mentally, we'll check it out in a second. Or you can come down here and use our Pythagorean Theorem. You see I've already set this up a little bit. Fill in these numbers. Well, I'm going to pause it just like so. Again, hope you paused that. You should have got 11,664 there. That should add up to that. You square root that. That does come out to 135. So, number 5. X isn't always the hypotenuse. Set it up. Okay. So again, this is my hypotenuse, leg, leg. So I'm going to have 77 squared equals x squared plus 55 squared. I got to go to the calculator just like you on this one. 5929 it looks like. 5929 x squared plus, let's see, this one, 3025. Do your subtraction. That's what I got after the subtraction. Square root, square root. Now we won't usually expect you to break down a square root that's this big, 2904. Smaller ones we do. And that's really important to practice those. The biggest problem most people have in doing better is not their ability to understand advanced skills. It's the basic skills. It's the arithmetic where people screw up. So depending on your calculator you put this in, you might get 22 square root of 6 is equal to x. Or maybe about 53.9 is about x. But I forgot to mention a couple of things here. Go back. This one is, yes, it's a Pythagorean triple. This one is not. 22 root 6, 53.9 is not it. So this is not a triple. Okay. Draw the diagram. Number 7, draw the diagram. I mentioned the example here. This is going to be kind of small. From school. So here's our school. You bike now I got this over. 1.2 miles due south. So I'm going this way. That's 1.2 miles. Then 5 miles due east. Well, due east is straight this way. That's going to be 0.5. Sorry, this is so small. Let's zoom in on it a little bit. If you had biked home on the street that runs diagonal, that would be this right here. Find the distance. Well, north and east make a right angle. So you've got a right angle here. You've got a right triangle. Find your distance right there. On these, verify the segments make a length. So that's where you have to do this 1 plus 1. The two short sides are less than 3. 1 squared is 1. You know square root of 3 should be bigger than 1. 2 is bigger than 3 because the square root of 4 is equal to 2. The square root of 4 is bigger than 3. I can make a triangle. Now I plug it into my theorem. See what I get. Get the 1 squared right there. This is going to be 3 and 1. 3 is greater than 2. We have an obtuse triangle. And I am out of time on this video. You have a good day.